Example, determine the exact values of the following expressions given that cosine theta equals negative 2/5 and theta is in between pi and 3 pi over 2. So let's think about what's going on here before we try to find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. Okay, well, if theta is between pi and pi over 2, then I know I need to be in quadrant 3, so I'm down here, and it's giving me that cosine theta equals negative 2/5. So what I want to do is use the fact that for my generalized trigonometry, meaning not just on the unit circle, so I want to think about cosine of theta as x over r, where r is the radius of the circle. And so I'm going to make x be negative 2. And again, I'm just looking at what's given to me. And r be 5. And again, r can't be negative because it is the radius of a circle. So I want to draw a circle of radius 5. And angle theta is in quadrant 3. So I'm going to draw that. So here's angle theta. And then I have some, just going to erase the quadrant 3 label here so I have room for my point. And so I have some r here, right? And then x comma y. And that's how I'm defining these trig functions in terms of x, y, and r. Well, I've already established that r is 5 and x is negative 2. And so now what I want to do is find or draw a right triangle. And I'm going to kind of blow that up and put it over here just so I have room to look at it. Okay, so here's a right triangle. And the little angle in here is actually the reference angle for theta. R, we know, we just pointed that out, is 5. X is negative 2, but lengths of sides of a triangle need to be positive. So opposite of negative 2 is 2. Okay, and now I want to find that y value. Well, first I'm just going to find the length of this side. I can call it whatever I want, say like a. And then I'll turn it into the y value when I'm ready to kind of put it in my diagram as an actual y coordinate. Okay, so what do I get? I get a squared plus 2 squared is 5 squared. A squared is 25 minus 4. A squared is 21. So a is the square root of 21. Okay, and then I know that my x is negative 2 just from my cosine. My r is 5, but now I've just found my y. And so what is my y? Well, the length of the triangle side is square root of 21, but because I'm in quadrant 3, I'm going down that amount instead of up that amount to get to the y coordinate. So I can see my y will be negative root 21. And again, that's just depending on which quadrant I'm in. So now I can go ahead and find my expressions that I want to find. So, like determining the value of sine of 2 theta. Well, sine of 2 theta is 2 cosine theta sine theta. So I just need one each of those factors. Okay, so here's my 2. What is cosine theta? I already know that. It's negative 2/5. Okay, well, what would sine theta be? Well, if I need to do a little work over here, I can. I know that sine of theta is y over r on a circle with radius r. And again, that means that I have a point that is on the terminal side of the ray, right, of this angle in standard position, and that ray is going to intersect that circle, okay? And so, let's see, I know my y is negative root 21, and then I know that my r, of course, is still 5. So what do I get here? These negatives are going to cross out, and so I get 4 root 21 over 25. And then that part is done. All right, what about cosine of 2 theta? So sometimes you have to kind of go up and go, which one do I want? It doesn't really matter which one we use, but since we were given the cosine angle, maybe we'll use 2 cosine squared theta minus 1. So this is 2 cosine squared of theta minus 1. So this will be 2. Take your cosine value. That was negative 2/5. That's being squared. And then take away 1. Okay. This is going to be 4/25 times 2 is 8/25. And taking away 1, well, we can think of 1 as, there's our thought bubble, that's 25 over 25. So 8/25 take away 1 is negative 17/25. So now we found the value of cosine of 2 theta given just the cosine value and the angle, and the quadrant that the original theta is in. All right, now let's look at tangent of 2 theta. What is that? Let's see. Tangent of 2 theta. So if we go up, it's 2 tangent theta all over 1 minus tan squared theta. Just double check that. Okay, great. So I definitely need some little work on the side where I go, what's tangent of 2 theta? And I go, wait a minute, that's just y over x. Okay, so I know what y and x are. Go up to remind myself. So I want negative root 21 over negative 2. So negative root 21 over negative 2. So just clean that up real quick. Root 21 all over 2. And so then I'm going to take that value, and that's what I'm plugging in here. So 2 times root 21 over 2 all over 1 minus root 21 over 2 squared. So what are we going to get there? I need a little bit more room. Okay, moving over here. So in the numerator, the 2 multiplying by that denominator 2, it just gives me root 21. And in the bottom, I get 1 minus, well, root 21 over 2 squared is just 21 over 4. And because I have that little mini 4 in the denominator, I'm going to multiply and just get 4 over 4. And this gives me 4 root 21 in the numerator, and then just 4 minus 21 in the denominator. This turns out to be a negative 17. I can pull out just the negative, and so I get negative 4 root 21 over 17.